Okay. Welcome to Miss Sciencey, where we explore all frontiers of science. Today's topic is quantum mechanics, the most counterintuitive field in science. So, before we begin, I'd like to ask you one question, or tell you one quote, let's say. The wise man Aristotle said that the more you know, the more you don't know. Now, this quote is very famous among anti-scientists. They say that the people of science themselves don't like science. But when Albert Einstein got another quote saying that science asks more questions than it answers, Albert Einstein didn't refute this hypothesis. He just said that it's better to ask questions about the universe than to know nothing about it at all. So let us begin with our question of the day. How is photosynthesis so efficient? To give a little background, this is how the photosynthesis process works. The, magnesium is the base atom of chlorophyll. The base atom means the entire molecule or the entire compound revolves around the base atom. For example, if let's say this is for example, let's say if this is the base atom, then this whole molecule will revolve around it without a say, like this almost. So now you can say the magnesium atom or the base atom is the most important atom of the molecule. Of course, you can't say this directly, but indirectly it is right. So let us begin. Now the sun rays hit the leaf. On the magnesium atom, they usually hit on the chlorophyll. This magnesium atom releases the exciton. This exciton is in an activated or an excited state and carries a lot of energy, potential energy. So, to use this potential energy, it has to get to the energy center. But there's a problem. Like it's like a big maze, like a large undivided maze where you don't even know where to look for this. Now let's see. The exciton takes this path. You're saying the exciton is probably just tweaking it or trying to do this the wrong way. But now look at it from the exciton's view. Look at this. Does this look easy enough to you to find where's the energy center? You could say that the energy center is for per se here or here, but you'd have no say until you saw the energy center yourself. You can't say if it is here or here or here or here. So to solve this, the hero of our story comes in: superposition. Superposition is one of the quantum mechanics most well known ideas. Superposition is the idea that a body can exist in two places at once until measured. Now you're saying that's not possible. Well, because that isn't. There's just only a small probability that it's either at let's say position X or position Y. But for the sake of scientists, this doesn't matter anymore. They just want to know if it is at position X or position Y. So they measure this atom. They find out that it is at position X. After measuring, we find that the particle is position X. The whole wave collapses, showing you that there is only the one particle at position X. Now, let's go to the next concept: Schrodinger's cat. You're saying, what is Schrodinger's cat? See, Schrodinger was a very famous scientist who revolutionized the field of quantum mechanics. This guy, he did a one small thought experiment. He was like, why? Now you're saying that it is possible at microscopic scales. But how is it possible at macroscopic scales? Schrodinger's equations told that the cat would be both dead and alive at the same time. But that's not possible, right? That's just wrong. That's why he sent out this polished version of his cat story to the world. In that, there is one atom that is there is one atom or molecule present in the radioactive sector. It either decays. When it decays, this pendulum, there is a kind of a pendulum. This pendulum breaks the glass, causing the poison to be released, and the cat dies. But the same thing, if the atom does not die, the pendulum is not really, the pendulum is not, moving, and the poison's not released. The cat's alive. Now the answer seems to be sitting right in front of us. This exciton takes every possible path, even the paths that lead it to become lost somewhere. But most of the time, when it takes all these paths, it takes the right path too, right? There are three, four, hundreds, and thousands of right paths to the energy center, and again, thousands of paths to the wrong energy center. But there is a 99.9% chance that it reaches the energy center through the said method. Now, now scientists really want to measure this. Poor Otto Loudon used Schrodinger's equations and everything to find out that this exciton can go to many places. But when he per se opened the box, tada! It only went one path. That is the right path. So what does this mean for physics? This is the new field of quantum biology, which has many concepts that it can apply in the day-to-day world. For example, this this is of course just superposition. This same thing could be said for quantum entanglement, or it could be said for the Heisenberg principle. So all these principles and in all these principles, yeah, you can say principles, use useful in biology. You can find the origins of life through this process. Thanks for watching.